Okay, we're still working in section 4.5. We're looking at double angle identities, and we're going to focus mostly on exact values here. In our first tutorial, we did one simple exact value question. In our second tutorial, we're going to look at what if they expanded a little bit. They say cos theta is in the third quadrant, it's -7/25, and we want to find all of those double angle identities, cos 2 theta, sine 2 theta, tan 2 theta. Now the first hint I'm going to give you is that we only have cosine. So if you look, cosine 2 theta can be found just by knowing cosine on itself. At number 3, with the cosine identity, we can use cos 2 theta in the form of 2 cos squared theta minus 1. Okay. Now we have cosine theta is -7/25, so we just plug that. -7/25 squared minus 1. So in our case here, that's 49 and 25 squared. Let me work that out here. 625. Okay, still working with that. 49 times 2. That would be 98. Okay, and still has a positive because we squared it there. So this would be 98 over 625 minus 1. So 1 is 625 over 625. So take 98 and subtract your 625. So I'll write it out here. Let's make sure that's still in view. Yep. So 98 subtract 625 over 625. And that's going to be -527 over 625. Now, there might be a common factor that comes out of that, so you'd have to be careful there, but I don't think in this case you can divide out of 5 or anything like that. So I think we're okay. Maybe a 3. Nope. Okay, so let's do the second part. The second part is a little more difficult in that if you're going to find sine, you also need to know the sine of cos theta. So of theta, pardon me, and you have to get that from the cos theta above. So you're going to be using the Pythagorean identity again. So to use B to get sine 2 theta, we have 2 sine theta cos theta. So we need to find this first. Okay? So if we're going to find that first, what we're going to end up doing here is we're going to use the Pythagorean identity again. So I'm going to just switch over here. Make sure that's in the field of view. Okay, so that's something we do a lot of, as you probably noticed here. So sine squared theta plus cos squared theta equals 1. Sine squared theta is what we're trying to find. Well, we're not trying to find the sine squared. We're trying to find sine. But sine squared theta, that's going to equal 1 minus cos squared theta. So sine squared theta equals 1 minus -7 over, what did I put it as? 25 squared. 1 minus 49 over 625. Okay, so that's 625 subtract 625 subtract 49, which is 576 over 625. This then equals, if I take the root, so we get sine theta is equal to, root of that is 24 over 25. Now we have to decide whether it's positive or negative based on the quadrant. It's in the third quadrant. We know that sine is negative in the third quadrant because it's if you're thinking of your ratios, it's y over r. R is always positive. The y is going down in the third quadrant, so this is negative. So now that we have the sign, we can apply the formula. So sine 2 theta is equal to twice sine theta times cos theta. Okay, so we have to take 2 times negative 24 times negative 7. And that gives us 336 over 500 or 625. So if we want to reduce that, I don't know if we can. 3 doesn't go into it. 4, 5 doesn't go into that one. So I think that will be our answer. Maybe it will reduce there as we can. So the last step then is to get the tangent one. And it's always easier, rather than using the tan formula for double angle identities, to use the quotient identity to get that answer if you know both sine 2 theta and cos 2 theta. So for question C, okay, let me make sure that's still in there. So for question C, tan 2 theta. So since we know both sine 2 theta and cos 2 theta, we can use quotient identity. Remember the 8 fundamental identities on page 139. So the quotient identity from page 139 tells us this, that tan theta, or in our case tan 2 theta, would be the same thing as saying cos, oh, pardon me. I better look that one up because I'm going to get it below. I think it's cos over sine, but let's just make sure. X over y is what I'm thinking. I'm pretty sure it's cos over sine, but just in case I see, look at that, sine over y over x, opposite over adjacent. So good thing I looked. Sine theta 2 theta over cos 2 theta. Don't assume. Okay. Just look at it. Okay, so that's a 2 theta, sine 2 theta, pardon me if it's hard to see. So let's work those out. Let's plug in our numbers for our 2 values. So we end up getting, for my first one, I had negative, let's see, for sine I had 336 over 625. And for the other one, I had negative 527 over 625. So these will cancel out, and we get 336 over 527 negative, because of the negative. And we can reduce that. I'm sure we can divide maybe there. Well, no, 3 doesn't come out, but there's our value for that one. So that concludes our sections for 4.5. As you can see, we spend most of the time working on exact value type questions, which is similar to what we've done in both in the sums and difference identities part from section 4.4. We'll be moving into 4.6 next, which is the half angle identities, and again we will be spending our time mainly working on exact values.